Hydroelectric power plants. What is a hydroelectric power plant? Hydroelectric power plants transform kinetic energy of water into potential energy. The fuel they use is water. How is energy transformed from one type to another in this power plant? The dam's sluice gates open and water falls into the penstock. Through the use of gravity, the water travels to the turbine. The kinetic energy of the water makes the turbine spin. The propeller's kinetic energy travels to the generator, and the generator transforms it to potential energy. Connected to the generator are power transmission cables. These cables take the potential energy to the transformer. The transformer changes the potential energy to a lower voltage, so it isn't too strong for the homes and businesses it will travel to. The transformer changes the voltage by following Ohm's law. The law states that V equals IR, or voltage equals electrical current times resistance. The conversion efficiency of a hydroelectric power plant. At power plants, not all of the energy is converted into the desired energy. The average percent of energy that is converted to potential energy at hydroelectric power plants is 95%. How does the electricity from the hydroelectric power plant get to the city? First, a company buys the power. One of the most prominent of these companies is BPA. The company sells it to utility companies or large industries. These industries are called direct service industries. The utility companies sell the power to businesses and households. Electrical potential difference and the exchange of energy between our homes and utility companies. Electrical potential difference is the difference between the potential energy of the charges with low potential and the charges with high potential. It is measured in joules per coulomb and is also known as voltage. The utility companies deliver the energy to our homes through power transmission cables. The energy sent to our homes has high potential energy. At our homes, the energy is transferred to other types by utilities. An example of energy being transferred or dissipated is by friction. When you use a vacuum, the friction between the vacuum and the floor causes the kinetic energy of the vacuum to be transformed into thermal energy. This causes the energy leaving our homes to have low potential. The power plant then does work by transferring more kinetic energy to potential and sending it to utility companies that send it to homes. How is the energy used in our homes? The energy enters a parallel circuit in your home. Parallel circuits are used because they are more reliable than simple circuits. Unlike simple circuits, if a part is missing or not turned on, a parallel circuit will still work. Parallel circuits are also more efficient. They have less resistance, which is how much the charge flow is impeded. When resistors, such as light bulbs and utilities, are added to a parallel circuit, the resistance decreases. When resistance decreases, electric current increases. Electric current is how many coulombs flow by a point in the circuit in a certain amount of time. The faster the electric current, the higher the voltage. Parallel circuits are also very similar to simple circuits. They both contain the required parts of a circuit: an energy source, conductor, device, and a switch. And they are both paths through which an electrical current flows. Not all of the energy in our homes comes from utility companies. Some of it comes from batteries. Batteries are in many objects in our home. They're in our computers, phones, and toys. Batteries store potential energy and are a chemical energy storage mechanism. Instead of transferring the energy, the battery holds it until you attach it to a circuit. Power is the rate that energy is used. Power is calculated as joules per second or watts. What is the cost effectiveness of a hydroelectric power plant? Hydroelectric power plants have the longest life expectancy by far. They last as long as 100 years, while the other power plants last about 40. The average operating cost of a hydroelectric power plant is only 1 cent per kilowatt hour, which is relatively cheap. The average capital cost per kilowatt for the hydroelectric power plant is higher than most of the other power plants at a range of $1,200 to $5,000. Based on this data, it can be concluded that the hydroelectric power plant is one of the most cost-effective power plants. Impact on the local environment and economy. Hydroelectric power plants can disrupt the flow of the river, which can block certain animals from migrating. It can also lessen water quality and cause human and animal displacement. Hydroelectric power plants are good for the environment because they are clean and a renewable source of energy. Hydroelectric power plants are a dispatchable resource. This means that they can generate power at a moment's notice. Hydroelectric power plants are also a source of many jobs. The social ramifications of hydroelectric power plants are people will have to move away to create space for the plant, and people will move closer if they have a job at the plant.